A random variable x is normally distributed with mean 3 and variance 2 squared. Find probabilities that x is equal to 2. Probability at the point for normal distribution is always 0. We can calculate probability only for some region, and the probability is equal to the area under the curve within 2 points. For example, probability that x is greater than a and less or equal than b is equal to this area, and it doesn't matter point is included or excluded. So we'll get the same result if we calculate probabilities that x is greater than a or greater or equal than a. So we'll get absolutely the same result. So probability that x is equal just one value, it means area is equal to 0, and hence probability is equal to 0. And probability that x is not equal to 2, and it's 1 total probability minus probability that x is equal to 2, so 1 minus probability of unwanted events, and probability at a point is 0, so it's 1. So probability that x is 2, it's 0, and probability that x is not 2, it's just total area, it's 1. And probabilities that x is greater or equal than 0 and less or equal than 2, so mean is given, variance and hence standard deviation is given, so it's just needed to calculate. We choose normal CDF, lower bound is 0, upper bound is 2, and it doesn't matter excluded or included endpoints, it will be the same. Mu is what? Is 3, it's mean, and it is required sigma, it's standard deviation, and standard deviation squared, it's variance is 2 squared, hence sigma is 2, and enter, and we get the required result. It's 0.242, 0.242 to 3 significant figures. B. Find probability that the absolute value of x is greater than 1. What does it mean? Absolute value is greater than 1. It may be 1 or greater, so x can be greater than 1, so 2, 2.5, 10, or any value up to plus infinity. The absolute value will be greater than 1. And also it may be any value which is less than -2. For example, negative 1. For example, -2, the absolute value is +2, so it will be greater than 1. So solution is, or we can rewrite this probability as probability that x is less than -1, or probability that x is greater than 1, and it will be useful since using a calculator we need lower bound, upper bound, since we need this region and this region. It will be useful to rewrite as 1 minus unwanted region, 1 minus unwanted region, and unwanted region it's in between -1 and 1. So we can rewrite as 1 minus probability that x is greater or equal than -1 and less or equal than 1. And just calculate. So 1 minus distributions normal CDF lower is -1, upper is 1, and same values for mu and sigma. And we get the result 0.864 to 3 significant figures. C. If probability that x is greater than some value c is 0.44, and we know the probability is area, so area to the right is 0.44. It's to the right from the mean, because mean divides into two equal areas, equal regions, and we need a value of this. Since mu and standard deviation are given, we can find easily this value of unwanted of this unknown value of x, which is equal to c, using inverse normal. Since x is required and area or probability is given, we choose inverse normal. And my calculator always asks area to the left from unknown value of x. So inverse normal and area, it must be area to the left from this value, so it must be 1 minus 0.44. Total area is 1, so area to the left it's 1 minus 0.44. Mu is 3 and standard deviation is 2, and just enter. And we get this value 3.30, so C is 3.30 to 3 significant figures. And that's all for this question.